Hello and welcome back. The following problem states gold crystallizes in a cubic closed-packed structure, face-centered cubic unit cell, and has a density of 19.3 grams per centimeter cubed. Calculate the atomic radius of a gold atom in angstroms. Well, in order to approach this problem, there's a few things that we need to identify. We know that they give us density, and we know density is equal to mass over volume. Well, in order to determine the radius, we need to first determine what A is of the unit cell. So in order to do that, we need to first determine what mass is so we can determine volume and plug it into the appropriate equations. So in order to find mass, we know mass will be equal to 4 atoms, because you have 4 atoms to a face-centered unit cell. So we have 4 atoms per 1 unit cell, and we can multiply this by Avogadro's number. We have 1 mole of angstrom, and I think you can see where I'm going with this, over 6.022 times 10 to the 23rd atoms of gold, multiplied by the molecular weight of the atomic weight of gold, which is 197.0 grams of gold over 1 mole of gold. Mole and mole cancels out, and we'll have a mass that is equal to 1.31 times 10 to the negative 21 grams of gold per unit cell. The next step is we need to determine the volume. So we have volume is equal to 1.31 times 10 to the negative 21 grams of gold, multiplied by 1 over the density, which is 19.3 grams per centimeter cubed. Remember, centimeter cubed is a unit for volume, and this is equal to 6.78 times 10 to the negative 23rd centimeter cubed. Well, the very next step is to determine what A is equal to. So in order to determine A, we need to take the root to the exponent. So in this case will be the root of 3 of 6.78 times 10 to the negative 23rd centimeter cubed. And this will be equal to 4.08 times 10 to the negative 8 centimeters. Well, once we do that, we can then plug A into the following formula to determine the radius. And so the radius, after we plug it in, is going to be R is equal to 1.44 times 10 to the negative 8 centimeters. And we want this to be in angstrom, so we have to use the conversion from meters to angstrom. So we have to first convert this to meters, and we know 1 centimeter is equal to 10 to the negative 2 meter. So centimeter and centimeter cancels out. We know 1 angstrom is equal to 10 to the negative 10 meters. Meters and meters cancels out. We are left with 1.44 angstrom for the radius of a gold atom in a face-centered unit cell. Thank you.